Hello all, welcome back to my channel. So in this video we will see some MCQs and some interview questions related to concrete technology. So these are the basic questions one must know while attending an interview, or they may be useful for some of the competitive exams. So let's begin them. So the first question is, what is concrete grade? So that's the basic question anybody asks. So basically, we hear the words like M20, M30, M40. These are all the grades of the concrete. So what is basically a concrete grade is, it is the strength of the concrete, which is specifically the compressive strength of the concrete, which is measured after 28 days on a 150 size cube. Okay. So when you say it's M20 grade of concrete, it means 20 is the compressive strength of concrete after 28 days. The next question is, what is M20 grade concrete? Just now I repeated. So in M20, the word M20, M stands for mix and 20 stands for the compressive strength of the concrete after 28 days. So 28 days is the specified age to decide the grade of the concrete, or to decide the compressive strength of the concrete. Then there's something called characteristic compressive strength. So what is characteristic compressive strength? So when people work on RCC, you have something called FCK. So FCK, and even when we are doing concrete mix design, we use the term called FCK. FCK is the characteristic compressive strength. So what is the difference between characteristic compressive strength and only compressive strength? So compressive strength is the compressive load divided by area, and which can be calculated at any age. But when you say its characteristic compressive strength, it is only after 28 days, and which is used as the standard compressive strength or the standard grade of that particular concrete. So when I'm saying M20 grade concrete, as I've just told, it is the characteristic compressive strength of concrete after 28 days. So when I say M20 grade concrete, here my FCK is equals to 20 Newton per mm square. So what is this characteristic compressive strength? So characteristic compressive strength is the strength of the concrete in which 5% of the results are not expected to, only 5% of the results are expected to fail. That is, 95% of the cubes should have the same value. Means, for example, if you are testing 100 cubes, 95%, that is 95 cubes, has to give you the more or less same result. Only 5%, that is 5 cubes, can have a lower value than the expected. So out of 100, if 95 cubes are giving the same result, you call it as a characteristic compressive strength. So it is 95% reliability, only 5% failure is expected. Moving on to the next question, what is the minimum concrete grade for RCC work? So for any RCC work, the minimum grade of concrete to be used is M20, not less than M20 can be used. What is the minimum concrete grade for PCC work? So for plain cement concrete work, you can use lower than M20. So one has to remember the value M20. So more than M20, I mean equal to M20 and more than M20, it is used for RCC work. Less than M20, that is M10 and 15, can be used for PCC work, that is plain cement concrete works. Next is, what is density or unit weight of a plain cement concrete? So for PCC, the grade is the density is 2400 kg per meter cube. And for obviously the next question would be, what is the density of reinforced concrete? So reinforced cement concrete, the density is 2500 kg per meter cube. So for PCC it is 2400, and for RCC it is 2500 kg per meter cube. What is the density of cement? Density is also called sometimes unit weight. So what is the unit weight of cement? Unit weight of cement is 1440 kg per meter cube. Next question is, what is the volume of one bag of cement? So this is very important question. So one bag of cement volume is around 0.0345 meter cube. This we will be using during mixed design of concrete. So 0.0345. Moving on to the next question, what is grade of cement? Just now we have talked about grade of concrete. So what did I tell grade of concrete? Grade of concrete is the compressive strength of concrete, that is the characteristic compressive strength of concrete after 28 days. Similarly, grade of cement is the strength of the cement after 28 days. So I'll just tell one point here. So when we're talking about grade of cement for OPC, we generally have three grades: 33 grade, 43 grade, and 53 grade. These three grades will be written on the bags of the cement. You can see cement bags with 33 grade, 43 grade, and 53 grade written, which is nothing but the uh, compressive strength is 33 Newton per mm square, 43 Newton per mm square, and 53 Newton per mm square. So one should understand that 53 is the highest value, means 53 is the high grade of cement which is having high compressive strength. So this 53 grade is used for high rise structures, whereas 43 grade is used for regular RCC structures, and 33 grade is less compressive strength, right? So this is used for basic plastering works. Moving on to the next question, what are the different types of concrete mixes we have? So we have three types. We have a nominal mix, which is also called as a standard mix, and we have a design mix and a trial mix. So coming to nominal mix is also called a standard mix, where we have some specified grades for M20, M30, sorry, M20 and less than M20, like M15 and up to M25. We have already Indian standard mix design procedure, or the what you call the mix proportions given to it. So these are the nominal mixes. So M25 or less, you call it as nominal mixes. Once you are going above M25, right, like when you start from M30, you have to design. There is no standard mix proportion given, so you have to design it, and this is called as a design mix. You have somebody third one called trial mix. So trial mix is that one, even though after doing a mix design, let's say I am taking M40 grade of concrete, so I have designed M40 grade of concrete using Indian standard code 10262. Okay, so after designing M40 grade of concrete, I will have some ratio of cement is to sand is to aggregate with some water cement ratio. So when I am drawing, when I have designed this mix design, directly I cannot send it to the client, or directly I cannot use it under application. First we will do a trial. So that mixes is trial mixes. So once you do the trial mixes, you have an advantage that if any corrections are there, you can do it here. You can predict how the actual concrete be like. So any modifications you want to do in the design, any checks you can do with the help of a trial mix. Moving to the next one, what is water cement ratio? So water cement ratio is nothing but the mass of water to the mass of cement which is used in the concrete. Generally for mixing the concrete, you have the, see, basic concrete. If you want to make, the raw materials are cement, sand, coarse aggregate, and water. So unless until you add water, nothing will happen. Like even if you have cement, sand, and aggregate mixed, you will not have any reaction, because water is the one who is doing the hydration reaction along with cement. So for this, you need to add water. It's One has to be very careful with this addition of water, because you add more water, the concrete may become very loose. When you add less amount of water, the concrete may become very stiff. So we have to decide with some water to cement ratio. So water to cement ratio is the ratio of water to cement. What is this importance of this water cement ratio? So just now we have seen definition of water cement ratio, which is mass of water to mass of cement. Importance is like, it decides the concrete quality, strength, and durability. One has to remember that more is the water cement ratio, less will be the strength. So if you are going on adding water, your strength can come down. So less is the water cement ratio, more will be the strength. And once the strength is more, the quality will be more, and the durability also will be more. So always try to adopt lesser water cement ratios. What lesser water cement ratios with super plus sizes can give a good workability as well as good strength. So how much should be the water cement ratio selected then, for especially if you're doing a hand mixing? Machine mixing, even at a low water cement ratio, you can achieve a uniform mix, but for hand mixing, it feels little stiffer when we are mixing with less water cement ratio. Then what should be the ideal value? So the ideal value of a water cement ratio, especially for hand mixing, is around 0.45, and a maximum of zero point 0.6 is also allowed. But generally, we take water cement ratios between 0.35 to 0.6. This is the range which you are free enough to select. But especially for hand mixing, you can take around 0.45. If you're doing machine mixing, you can go up to 0.5, 0.6. See, this all depends upon, are you using any super plasticizer or not, only simple water you are using. Then what do you mean by workability? Now when we are talking about water cement ratio, something called workability will come into action. Just now I told when we are mixing with hand, if you're using a lesser water cement ratio, that is when you're adding less water into your concrete, you feel little stiff mixing, you feel that difficulty. So what we do to overcome the difficulty, we add more water. But when you're adding more water, what is happening, the concrete consistency is keeping on increasing. But at some point of time, you can have a problem of segregation bleeding, which I'll be talking in the next question. So talking about workability is technically defined as the ease with which the concrete can be mixed. So the ease, the uh, feeling or the consistency with which you are mixing the concrete, you are transporting the concrete, then you are placing the concrete, that is you're molding the concrete, and you're compacting it. Even after doing these many stages, your concrete should not get segregated. That's then you say the concrete is workable concrete. And coming to segregation, just now I told, as we are increasing the water content, the workability of the concrete will increase, but sometimes you may end up with segregation. Segregation is nothing but the separation of the materials of the concrete. Just now I told we have cement, sand, aggregate, and water. So if you are adding more amount of water, these three particles can be on one side and water can come out on the other side. Or sometimes if you are doing heavy compaction, cement and sand, that is cement plus sand, that is your mortar, can be on one side, your coarse aggregates may get separated on the other side. So when you are dropping the concrete from bigger heights also, the segregation problem can occur. Then we have another failure in concrete, which is bleeding. So basically segregation and bleeding are the failures in fresh concrete. So segregation is separation of materials, whereas bleeding is the rise of water onto the surface of the concrete. So this happens because of the excessive settlement. See, one has to remember that in cement, uh, sand and aggregate and water, the material with the least specific gravity is water. The specific gravity of water is 1. So the least specific gravity among these four metals is water. So the one who is having lesser specific gravity generally tends to come up. So if you're doing over compaction, if you're doing over vibration, this water can rise up and it forms like a layer, which we call as latents. So this is called as bleeding. And talking, what are the other properties of fresh concrete we have to look about? We already saw workability. Other than workability, we have segregation, bleeding, plastic shrinkage. That is the shrinkage which happens after immediate pouring of the concrete during the setting time, during the immediate setting, and water cement ratio, temperature, and setting time. I have all made videos on these topics. Kindly you can look at the playlist of concrete technology in my channel. Moving on to the next question, what is slump? So workability is generally measured by different tests. We have slump test, compaction factor test, flow table test, VB test. So in this we have one important test, which is slump test. Slump test is both a laboratory test as well as a field test. So we generally use slump test for determining the concrete workability. So slump test is used for measuring the property called workability. So what are the different types of slumps? So different types of slumps, we have true, shear, collapsing, zero. So we have, once we do the concrete slump test, we can expect the following shapes of slump. True slump. True slump is the one where your concrete will just subside very short and maintain the marble shape, whereas which is the most desirable workability for any concrete construction. When you have the some when you we can also observe somebody called shear slump. Shear slump means one half of the cone will slide down and like it looks like an inclined plane. When you look at the collapse is completely a fresh concrete. Once you lift the cone, will collapse. Zero slump is the one where the concrete maintains the axial shape of the cone, like means there is no fall of concrete after lifting the cone. So when it is a zero slump, we say absolutely the workability is very low. When it is collapse, very high workability. Shear slump, high workability. True slump is a good to medium workability. And what are the dimensions of a slump cone? So generally we perform slump cone test on a cone whose bottom diameter is 20 centimeters, top dia is 10 centimeters, and the height of the cone is 30 centimeters. So based on, after placing the concrete into the cone and after lifting the cone, how the concrete subsides is that we decide this, whether it is a shear slump or a collapse slump or a zero slump. Next one, what is the concrete cover value for different RCC members? So for a slab, it is around 20 mm. That is, this is the minimum cover, and it can change. So minimum is 20 mm, for beam 25, column 40, and footing it is 50 in mm. Next is, what is the standard size of concrete cube? Just now we have seen concrete strength is based on the cube. The cube dimensions are 150 mm by 150 mm by 150 mm. That is 15 centimeter. And moving on to the next question, how many samples are filled for 1 meter cube of concrete? So generally, for we design concrete for 1 meter cube. So for if your concrete volume is between 1 to 5 meter cube, we make one sample. 6 to 15 meter cube, we make two samples. 16 to 33 samples. 31 to 50 meter cube, four samples. If it is 50 meter cube and above, then we make four samples plus additional one sample for every each 50 additional meter cube. One has to remember that one important point here. Here, one sample means three cubes. Which means if I am making a concrete in between the volume of 1 to 5 meter cube, it's one sample, means I have to cast a minimum of 3 cubes. Next question, how much concrete gains strength after 7 days? So basically after 7 days the concrete reaches a strength of 65 percentage. So it is said that after 1 day the concrete will reach a strength of around 16 percentage. After 3 days it's around 40 percentage of increment, I mean gain, sorry, it's not increment, gain. After 7 days it is 65, after 14 days it is 90%, and after 28 days it is 99. That's why we generally test the concrete at 28 days. This factors affecting the strength of gain of concrete I have explained in one of my videos called factors affecting strength of hardened concrete. Do check out in concrete technology playlist. And next question, what is soundness of cement? So soundness of cement is basically a property of cement which does not show any expansion, which does not show any changes in the volume once it has been set. So generally we measure the soundness in mm, that is expansion, amount of expansion. Generally the cement is said to be good if the expansion is less than or equal to 10 mm, not more than 10 mm. And the most asked question, what is specific gravity of OPC cement? Generally the specific gravity of OPC cement varies in between 3 to 3.15. And we have the next question, what is shotcrete? So shotcrete is the technique of pumping the concrete or spraying the concrete with a small aggregate size. So we generally pour the concrete into a pipe, and we fit a nozzle, and then we jet the concrete with very high velocity. So this type of concrete is basically used for repairing of structures and for tunnel lining, etc. And we have somebody called honeycombing. Even after concrete setting, once you remove the formwork, that is once you do the deshuttering, sometimes we find honeycombs. Honeycombs means you have to, you mean you see some voids or cavities on the concrete surface which are basically formed due to improper filling of the concrete. So when pouring of the concrete, with if you do not do the proper compaction, you may end up with honeycombs. And the last question, what is the normal consistency of OPC cement? So generally normal consistency will range between 25 to 35 percentage. This normal consistency is represented by P, and this value is important for measuring all other different properties of cement like your initial setting time, final setting time, soundness, compressive strength, etc. So I hope you all understood the video. Thanks for watching.